Okay, so in this video, I wanted to go over loan amortizations. You know, when you talk about time value of money, there's lots of ways to come up with examples or calculations. But a loan is a very common one, and calculating a loan amortization can spell out the exact schedule that you would be making payments. What I like about using Excel is you can actually vary or change any of the variables and see the results. You can total interest really quick and see what a true loan would cost. It's easy to also deal with it per month or per year, so it's just a really good tool. So in this video, I want to go over the development of a loan amortization schedule using Excel and also time value of money. Let's take a look. All right, when you pull up an Excel document, I've blown this up hopefully that you can see well enough. And so we're looking at information. I've got the text of a loan. There's the value in a different cell. I've got time as 10 years at a different cell. And then I've got rate as 6.5%. Now that 6.5% is actually in Excel. You've got to put in the decimal and then you would show and change it to a percent value. And that's how I got that number to show up there. So versus your calculator, you actually type in 6.5. When you deal with Excel, you're going to type in 0.065 to adjust that. All right, now what about a yearly payment using these variables? Well, there's a lot of ways to get to this. Probably the easiest is the f of x function, and it pulls up recently used ones, or you could search for them. And there is one for a payment. If I double click on that, it starts asking me about the variables. Same thing we did in our calculator. Well, from an annual perspective, there's the rate. From an annual perspective, there's the time. And from a present value perspective, remember the negative in front will help us. There's the business loan. Now this $750,000 would be an example of maybe a cash flow loan that was given to us to start up a business, and we're going to pay it off over a 10-year window. So that's $104,000 a year that you would end up paying if you paid yearly. What about monthly? Well, it's the same exact idea, except the rate is going to be divided by 12. So we make that adjustment right here. You can see also that time would be 10, but we're going to multiply that times 12. And that gives us our answer. And then we're still dealing with the same amount of present value borrowing up front today. And so when we hit enter here, you're looking at $8,500 a month to get this done. So these are two ways we can calculate these. And so now let's look at the loan amortization. And I'm probably going to focus on the monthly because that's probably likely the best way you'll end up paying this back. If we focus on yearly, we end up with quite a bit less, of course, payments. But we can do this easy on our Excel sheet. So what are the variables we need in a loan amortization? I always start with time, and time will be at time value 0 and then a 1. And I need it all the way out to 120 to deal with our loan amortization. So I just copy this all the way out. Gets me to 120, and those are the payments. All right, so then the first variable I usually deal with is going to be what is the payment? Well, the payment is equal. It's already calculated. It's that number right there. And then every period, it's going to be that exact same number again. And so there's a couple of ways to do this. One is you could just lock this cell as well and say it's just going to be B8 all the way down. So we can actually do it that way, maybe be better. At time value 0, you don't pay anything. You're getting the loan started, so you'll make this payment after the first period is over. All right, well, a loan payment always represents a couple of things. It represents principal, and then it represents interest. And that is really the value of a loan amortization table, to split these up so that we can see it. Well, the payment is what that represents, but at the end of the day, you end up with a loan balance. So actually, we don't pay any payment today, but we do borrow today. And we borrow that loan amount right there. And so at time value 0, that's your loan right there. Now, the principal and the interest payment are off of again there. Well, interest is the one to calculate first because we know that that is our balance. And we multiply it times that rate, but we need to take that rate and divide it by 12 because we're talking about a monthly rate. And that means that that's going to be dollar symbol $4,000. So about half our money is interest right up front. So what's principal? Well, it's going to be that payment minus what we have to pay in interest, and left over is principal. At the end of this first period, well, your balance was that number. We deduct the principal off of that, and now your balance goes down. So this formula is using our monthly payment, is locked. This formula is taking the difference between these, which we want to replicate. This formula is looking at your previous year's balance times that rate. I want to lock that rate in there. I don't want 5 to change to row 6 and on. And then your balance is going to be whatever your previous balance was minus principal gives you a new balance. So I can now take all of those formulas, and I think they're all locked as they should be. I'm going to run a copy of that down to my 120 payments, and there is my check. The loan is paid off in 120 like we said, and you can see the principal and interest that goes along with that. Of course, totaling these kind of gives us some insight. From a cash flow standpoint, across the 10 years, we'll be outflowing a little over $1 million. In terms of principal, we're paying back the $750. In terms of interest, we are paying back them $271,000. So what does this really cost us? It cost us $271,000 across all of these years. If we can earn more than 6.5% on this money, then this was a good idea, because it's going to cost us this interest every month, which of course totals of the first year to be, in this case, $47,000. So we're going to have to earn more than that off this money to make this a good idea. And again, there's your rate to compare to. So when it comes to capital budgeting, we might start to think more about, well, if you can borrow at this rate, what would it actually earn you? But this is a common table to calculate, and Excel makes it easy. Now, if you started to change things, like I tell you what, this earnings is more than I can pay. What if I could give a collateral, maybe of land, where the bank would say, you know what, that's a whole lot less risk to me. So what if we can negotiate a 6% loan? You'll see things drop here, and so right now we're looking at a $271,000 cost. Dropping it to 6% would take that cost down to almost $250,000. Still paying it off when we're supposed to, so everything's working out. Still paying the same amount of money, costing us just under $1 million. So you're saving the 271, so you're saving like $20,000 across here. It's really not a very big difference between that. So you kind of get to understand what these values are. If you change this to a 9-year payout, then of course you're having to pay a little bit more money, but we're going to pay this thing off in 108 payments. These no longer are necessary because we're paying them off earlier. So you kind of have to get these out of your way if you wanted to look at what this cost. And so we kind of maybe could go through here and get rid of those. And so you're paying $222,000 now. So you're like $50,000 off by bumping it back a year off what we originally looked at 10 years. So you're able to use the results of these calculations to develop a time value of money or a loan amortization. So in this week, we've got some resources for you here. Hopefully this helps you understand this. Make sure to look at the assignments for the week too.